we can observe not only in your arithmetic and pre-algebra classes and Algebra 1 that every operation has an inverse, an operation that undoes the other. Addition has subtraction, multiplication has division, and now we're going to be learning about the inverse of exponents. I'm going to use that as a symbol for an exponent. Now, what is the inverse for an exponent? Well, that's what I'm going to be breaking down for you today. And spoiler, it is called a logarithm. So, erase this. See what's up. Say we had 2 to the x raised to the 32nd power. Now, if you don't know this off the top of your head, you might not be able to answer this very quickly. And if you don't know your powers of 2, then this might seem just a little bit far-fetched for a sec. But let's think here. Maybe instead of trying to simplify this, we can rewrite this so that we can just look at it a little bit differently. We're going to take the logarithm of this. Now, what a logarithm does, it rewrites this expression so that you can look at it from a different perspective and maybe even solve it easier. Now, a logarithm, I'm going to write down the standard form of a logarithm just to show you. Log B A is equal to C. This reads log base B of the argument A is equal to C. Now the base here, this refers to the base of our exponent. So we're going to write this as log base 2. The argument, we're trying to find the solution to this. So this right here is our argument. So log base 2 of 32 is equal to the conclusion. The conclusion is what we are trying to find, our x. So it's kind of like a switcheroo. We're bringing the 32 over here, bringing it down. Log base 2 of 32 is equal to x. This is the action of rewriting it. Remember this process of this being our base, this being our conclusion, this being our argument, and this being our conclusion, the conclusion being what we want to find. It's the same thing as saying 2 to what power is equal to 32. So 2, let's think about it as growth. How many times does 2 have to multiply itself to get to 32? Well, it has to do it 5 times. Log base 2 of 32 is going to be equal to 5. Let's have a look at a different equation and then use logs to solve it. Here we have 3 to the power of x minus 1 is equal to 9. Now we're going to rewrite this the same way we did last time. I'm going to rewrite the standard form of a log down here just to remind you. Log base b of a is equal to c. Now b is going to be our base. We're going to take the log of 3 right here. So log base 3 of the argument, our answer right here, 9, is equal to the conclusion, which is going to be our exponent right here. Now, I must clarify that the conclusion is not just the x. It is the entire exponent, whatever is up there. The same goes for the argument as well. If the argument right here was x plus 1 and it was 3 to the 9th, this would be log of 3 of x plus 1. So here, we're going to make x minus 1 our whole conclusion. Just going to close that real quick. So log base 3 of 9. 3 raised to what power is equal to 9? Well, that's 3 squared. So log base 3 of 9 is equal to 2. So 2 is equal to x plus 1, no, x minus 1. So we just add 1, and 3 is equal to x.